All right, now let's talk about memory allocation. I'm going to show you exactly what happens under the hood when we create new objects in Java. So Java manages two different areas of the memory. One is called the heap, and this is where it stores our objects. The other area is called the stack, and this is where it stores short-lived variables, like all the primitives, as well as the variables that store references to objects on the heap. What do I mean by that? Well, look at this piece of code. When Java runtime executes this, first it will evaluate what we have on the right side of the assignment operator. So it will create a new text box object and it will store it on the heap. Now, let's say the address of this object on the heap is 100. Then Java runtime is going to execute this other part of the code. Here it will allocate some memory on the stack, and in this memory location, it will store the address of our text box object on the heap. So this variable that we have here is referencing an object on the heap. That's why we refer to these variables as reference types, because these variables don't store the actual values. Primitive types, on the other hand, are different. When we declare an integer, that integer is stored on the stack, and the value that we have in that variable will be stored in that memory location. Now let me show you something interesting. Here I'm going to declare another text box variable, and I'm going to set it to text box 1. So once again, we're using the var keyword. So we're letting the Java compiler detect the type of this variable. It will look at what we have on the right side. It knows that this variable is a text box object. So the type of this other variable will also be the text box. Now, here's the interesting thing about this piece of code. In this example, both these variables are referencing the same text box object on the heap. So we don't have two different text box objects. There's only a single text box object on the heap. And we have two variables on the stack that are referencing this object. Because on line 7, we're copying the value that we have in this variable into this other variable. What do we have here? It's the address of our text box object on the heap, like 100, right? So with this piece of code, both these variables are referencing the same object. And that means if I modify that object through one of these references or one of these variables, the changes will be visible to the other variable. So here I'm going to use the second reference, the second variable. And with this, we're going to set the text to hello world. Now let's print the value of the first text box. Because both these variables are referencing the same object, the changes are going to be visible. Take a look. So we get hello world, and this proves that both these variables are referencing the same object. Now, what about memory deallocation? Well, in Java, unlike C++, we don't have to worry about deallocating memory. Java will automatically take care of that. And this is how it works. When we exit a method, Java runtime will immediately remove all the variables that are stored on the stack. So in this example, these two variables are stored on the stack, and they will be immediately removed after we finish executing the main method. Now we end up with an object that is on the heap, and there are no references to this object. So there is another process in the background that is watching these objects on the heap. If an object becomes unused for a certain period of time, that process is going to automatically remove that object on the heap. This is called garbage collection. So Java runtime has this component called garbage collector, which will automatically remove unused objects on the heap. So this is all about memory allocation and deallocation in Java.